Okay, thank you. I appreciate it. Let's see. I don't know if you've seen the chat and all that. I'll just leave it on the side here. Yeah, thanks for the opportunity. Really appreciate Ray's and Yvonne's invite, and I want to thank Dan Kilper as well. I worked with him on an NSF Smart Cities grant, and came up with these ideas. One of these NSF grants. The other one is on high-speed optical file transfers, and the DOE grant as well. We thank them. So, want to talk about let's see, two applications. Sorry about that. This is what the title that's listed in the agenda, and this is that smart city application that Dan Kilper and I have been working on. It actually has all three words that Cosmos, all three phrases that Cosmos uses, and we definitely want to use wireless for that. The other one is a pure optical network play, and many of you know I worked on wireless years ago, but more recently I've been in this space. Okay, so coming to computing models, I mean, this is the model we're all used to, right? So we have a desktop or a laptop, and we install Word on it, or I use Apple Mail on mine, and run web browsers and so on. So this is model one. Model two that's become real popular these days is SaaS. So we use Google Docs instead of using Word on your laptop. So even the photo editing, instead of having it here, you leave it in the cloud. And so, but I didn't know much about JavaScripts, and it turns out for all these apps, JavaScripts are downloaded. You do need a web browser on your laptop, and so if you have a bad laptop, like cheap machine, the quality will be bad. So remote desktop computing is the third model, and this is used frequently. So what happens is you have essentially, say on an edge cloud server, you run your apps, and so this could be fine machine, $2,000 machine, and so the performance is really good. And all that you're doing is sending your keyboard input from here and getting your display updates. Years ago, when I was in Bell Labs, we used to use VNC all the time. Now TeamViewer seems to be pretty popular. But still, what you have here is some kind of a PC with a processor and so forth. So the model that we got interested in, and then even if the only application you need to run here is the client. Even your web browser would run here, and if you're doing web browsing, the data would come here, the page would get rendered there, and then your frame buffer would get pushed. And so this particular NSF project, we have Harlem as a partner, and we were talking about getting broadband access, broadband internet to homes, to some of the homes that were lacking it. When Silicon Harlem, who's part of your Cosmos team, Clayton Banks there said, well, some of the households don't have PCs, and so we started exploring that, and so we said, okay, would this solution be cheaper where the homes just have a KVM, so it's like $100. And so this is called a zero client model. I don't know how many of you heard this term. It was new to me. What we wanted to do, we didn't know about this actually, at least I didn't know about it. I think Dan knew a little bit more about it than I did when we wrote the proposal. I was thinking we should build an FPGA-based system here with no processor. I've become completely anti-processor, and I'll tell you why in a minute, at least for user-owned equipment. And so it turns out, so we, in our original proposal, we drew out an FPGA design. It needed three things, right? It needed to implement the client end of the protocol. So there's a company called Teradici that has a protocol called PC over IP, and Microsoft has RDP, VMware Blast, and this is an IETF standard, remote frame buffer protocol. So you're sending the keyboard input this way, so you better encrypt it, right, if someone is typing a social security number. And the display update that's coming this way better be compressed, because if you want high quality video, the amount of bandwidth you need is pretty high. And so it turns out, and again for web browsing, if I were to add web, oops, I didn't add the web browser there, that would still run this. This looks very much like Model 3. So the difference is what the user owns does not have a CPU. And so this is LG sells the Zero client, and I'll tell you more about this. So you just connect the keyboard, mouse, and so on to it. So that's the idea. And really we share everything these days. I hear people share pets and clothes, but we don't share desktop computing for residential use. This is more popular in the business side. So I've started working on cybersecurity, and I have a DARPA project on that, so this has become really interesting to me. So, well, if somebody attacks your enterprise, you lose your data for yourself, it's a big deal, but in a way not a very big deal, like the Target attack. But the WannaCry attack, what it did is, if your computers are badly protected, it can take that over and spread. This spread to 200,000 computers in 150 countries. So I was thinking, to protect against ransomware, I don't know if you all saw some of the 60 Minutes show just a couple of weeks ago, where a bunch of small city governments, town governments, municipalities, and so on, they're getting attacked, their computers are getting taken over, and I'm like, why don't we just put their storage in the cloud, right? So that's fine for that, but as long as those governments or residences have computers that are not protected, those hosts could be used to spread the attack. So I call them bad netizens. So really, this has become my mantra these days, and that if you anything that's user-owned, not a professional administrator should not have a processor. So the Mirai attack, which used nanny cams, is another example. So it's really, I think the zero-client model, the huge, huge advantage is that it will reduce the cyber attack surface of the internet. That's a line that Kevin Thompson gave you, and I was just giving insight to him from NSF. So here we talk about, the other thing is the cost, and it's not so much like you say, okay, if you think about an enterprise deployment like at UVA, we spend a lot on admin because every staff member has a computer. So I could go on and on about the advantages. There are a bunch of disadvantages. You lose freedom. The question is, you're totally reliant on a network. How good is that? Is that a good idea or bad idea? So I know I'm going to go over the disadvantages fast. Those should be discussed. So the vision is in Harlem. Dan has made good progress in sort of deploying this. He's getting a Microsoft gift with computers, deploying, say, the computers here as an edge cloud, and then all these buildings, we're hoping a whole bunch of them could switch to KVMs with zero clients and use wireless. Well, some folks would still have PCs. Dan likes this phrase, disaggregated computing device, where the I/O is in the home, and the CPU, memory, and storage are here. And also you're sharing the access instead of having broadband coming into each apartment. It would just come into the basement, and then hopefully this could be, well, you would need 10 gig going to every Ethernet switch if you want to have end-to-end 10 gig, but that's another story. So the existing landscape, turns out Teradici is a company that already makes a chipset, and it's called TER2321. It's been there for a while. It's not a general purpose processor, and so it can't be attacked as easily. It doesn't run a generic operating system. And they've implemented this PCIP, but they've licensed that chip, given that technology, to these companies that make the zero clients. So we've actually purchased zero clients from LG, Dell, and HP, and we've experimented with them. On the software side, the two technologies, Linux users would find it pretty, obvious that many users use Linux, right? Use the Linux system. But like if you have a Windows desktop, there's only one user that can use it at any given time. You need Windows Server and RDS running on it for sharing. Now this VDI concept is you have VMs, and I'll show you a picture, and each user gets one VM. So on the enterprise business side, this is now being offered as a service. You can get it on VMware Cloud, which I think is VMware is going away from this, but Microsoft and Amazon offer this. And so it looks like this. You have you could either have a zero client or you could have a thin client, and a thin client you're running PCIP software. I know I'm talking a lot about the application. My last slide is on desired features from the Cosmos testbed. So you would this is your Ethernet network, that is your edge cloud host, and this is what folks would have. So that's what the picture looks like. So my student Malathi, who just graduated with a PhD, got to hood her yesterday. I was rather excited, or a couple days ago. But what she did was she took a bunch of applications, and this was just a single test, not a scalability test, right? You have one user with a zero client, and the applications were running on the edge cloud, and packet loss rate of 10%, I could tell you, was unrealistic, but she wanted to understand what the impact was. And she played video on the edge cloud. And what happens is PCOIP, the protocol, if it senses that the network is really bad, it will drop the amount of bytes being sent. And so she used frames per second and another video quality measure from a 2003 paper called slow motion video quality, and showed that those dramatically drop if your network is not good. I mean, worst case, your network is not available. So she did this kind of experiments with different applications, and we submitted a paper. But in what she did, the work, this idea of one user has one zero client and connects to one VM, it's not very cheap. And so enterprises can afford it, but it wouldn't really work with like residential customers, like if you're trying to bring it to a smart community, like Smart Harlem, Smart Harlem, and so on. The second problem is you can't send video upstream, like that hardware, that chip, only has the decoder for the video, not the encoder. And Wi-Fi wasn't supported as well. So I have a new student, and two of my students are in the audience. I'd like to introduce them, Ija, Zhang, and Hongying Dong. I think Hongying will start working on this. She's just joined my group. So we have a couple of other students, David Kasey, who is experimenting with this. This is a really complicated slide, and I probably shouldn't have put this up. But VMware sells this software called Horizon, where you have a Horizon client, and on the edge cloud, you can either run RDS farms or you can have desktop pools and run VDI. So both services can be supported. And there are two protocols, PCOIP. It supports actually three, RDP and also BLAST. BLAST is VMware's own protocol between clients and the desktop. Okay, I'll try to speed this up a little. So on the business enterprise side, this is a done deal and it's already deployed. So the question is, to get that huge impact on reducing cyber attacks on the internet, we'd really like to bring it to all kinds of other sort of contexts. And the residential context is what we are working on in that project. There's a lot to do there to get this deployed, or get all the technologies built to deploy this at smart communities. But the one I'm excited about is like students. I started picturing my class. I usually have like 70, 80 students. Imagining none of them have computers, like laptops. They all have KVMs. And just like you have power at every desk, you would have zero clients. I've noticed this in a hospital, like all the administrators now, they just have a terminal, and if you look behind them, it's a Dell Wise zero client. So these companies like Dell have been able to sell this model to enterprises like hospitals, but I've noticed that instruments still have PCs connected to them, and I was wondering if you could move those. But the thing that makes I don't know if this will work at all is cell phones, right? Cell phones, everybody's making them smart. I'd like to make them dumb, and run all the apps on the edge cloud with just a 5G wireless interface. So could we do this sort of thing? So to test this on Cosmos, I Ivan sent me, I asked him for slides, and so did Dan Cooper. And I think my understanding is that you'll offer all of these to be shared by experimenters, and this was my question. And at the end, if we have a few minutes for discussion, I'd like to ask about that. Just a couple more slides. On the other application that we have, now I'm doing a total context switch. this is for just the optical test bed. It's nothing to do with wireless. We in 2015, so say from 14 to 14, 16, during this period, I had funding from DOE and from the what is today the Office of Advanced Cyber Infrastructure. It used to be the OCI and ACI. What the work we did was with like folks like ESNet and Internet 2 was to see if we could get high throughput for large transfers across high BDP paths, right, bandwidth delay paths, where you're talking about the rate kept changing. I did this work for a long time. It went from I think 10 gigabits to 40 gigabits, and now we're getting experimenting with 100 gigabit transfers with like 40 gigabit NICs and so on. And so when you have such high bandwidth and you're going across the WAN, even the high-speed TCP versions don't work well. So the question is, could we just set up a circuit? And we did this with layer 2 paths, using all this SDN stuff to provision an end-to-end VLAN. This is the old ATM. I don't know if Ray remembers, but we met in the ATM forum and that sort of thing. And then on the data plane, you basically pace out packets at a certain rate. I talked to Jack Brazel about this, at the rate of that circuit. And so the question is, I've been dying to try this on layer 1. Talked to Sienna, and we had good plans, but then it didn't pan out. The guy who was working with us left, and that caused issues. So when Cosmos when Dan started talking to me about the optical part, I was really excited. I think we have all the pieces. We have the data centers, so we can log into those, and then we have to integrate grid FTP with this so-called circuit TCP. This is TCP without congestion control, and then we could do grid FTP offers all this type of stuff to achieve really high rates. And then on one of Ivan's slides, I saw RDMA, and Ezra Cazal, Martin Swain, and Brian and Eric. They've done some good work with RDMA and shown on L2 VCs really good performance, and would like to try that on L1. So the last slide, desired features. So for this zero client classroom setting and the mobile phones, I was wondering whether you all had laptops with 5G wireless. I don't know anything about 5G. I've not been working wireless at all. But clearly you can't do wired. So is that something we would have access to, and any plans for phones or the ends that connect into the 5G? And on the optical side, really what we need is a programmatic API to the SDN controller so that we can dynamically set up the circuit, do the transfer, and then release it. For that level of sharing, it's not packet by packet sharing, but call by call sharing. Also want to see what this elastic optical networking can do in terms of quality, BER and things like that, if we have lots of connections at the same time. And RDMA NICs, definitely want to try grid FTP over RDMA. So those are the ideas I had. Love to get some feedback and then go from there. That's it. Thank you.